Alright guys, we're going to talk about solving some trigonometric equations here. That basically what we've been doing, but this time we'll have to do a little bit of algebra to get that far. So I'm just going to do a few examples for you so you're got what's going on here. So what if we have 2 sine theta minus 1 equals 0? So this is a real basic one. Just do your algebra manipulation. If I add 1 to both sides, I'm there. I can divide both sides by 2, and I've got sine theta equals 1/2. We're going to do on over the interval from 0 to 2 pi. So, now it's exactly like what we were doing the other day. So, where is sine positive 1/2? It's in the first quadrant and the second quadrant. So, theta is pi over 6 or 5 pi over 6. So another example where there's a little bit more manipulating to do. If I have 5 cosine theta equals 3 cosine theta plus the square root of 2. So it's going to be more about combining like terms. This and this are like terms. Okay, we can combine those. If I subtract 3 cosine theta from both sides, and I wouldn't necessarily always write that for demonstration purposes, I am. Now I'm going to divide both sides by 2, so I have cosine theta equals square root of 2 over 2. So that cosine is positive in 1 and 4. It's going to be our over 4s. So pi over 4 and 7 pi over 4. Okay, so there's that kind, which are basic solving. Now one thing you have to be a little bit careful of is, here in example 3, if I have 2 sine squared theta equals 1, I can divide both sides by 2. I can square root both sides, but remember when you square root both sides of an equation, you need that plus or minus. Okay, so square root of 1 is 1. So and square root of 2 we have to leave, so we still have our plus or minus. If we rationalize, that's square root 2 over 2. So sine theta. But so we need all 4 of them. We need the positives and the negatives. So and it's the square root 2 over 2. So it's our over 4s. So it's pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now we are going to have to remember some of our other algebra techniques. If I have something like 2 cosine theta sine theta equals negative cosine theta. Now those are not like terms, but what I want to do is get it equal to 0. So when I move that negative cosine theta from the right to the left, it's going to be plus. And now I have to use different factoring techniques on the next couple of examples. I can factor out a cosine theta, which leaves me with 2 sine theta plus 1 equals 0. Has to be equals 0 or our factoring doesn't help. So either cosine theta has to equal 0. Okay, cosine is 0 when we haven't gone left to right at all, so that would give us solutions of pi over 2 and 3 pi over 2. Okay. Or sine theta would have to equal negative 1/2. With 2 sine theta plus 1 would have to equal 0. Sine is negative 1/2 at 7 pi over 6 and 11 pi over 6. It's negative in quadrants 3 and 4. So I should write the solution set as one big solution set. I suppose ideally if we had them in order that would be nice. If they're not, it's not too big of a deal. So we get our solution set there. Okay, so that's one. Remember you can factor out. Now you can also use factoring techniques that involve like factoring trinomials. Okay, so, oh, I should point out up here too, do not divide both sides by cosine theta at the beginning, because if you divide by anything that involves the variable, you could lose solutions. So do not, at the beginning of that, divide by cosine theta. Okay. Alright, just two more quick examples here. If I have 2 cosine squared theta minus 3 cosine theta plus 1, so equals 0. If you have cosine squared and cosine in the same equation, you are going to have to do like factoring trinomials. We would factor this the same way we would factor 2x squared minus 3x plus 1. Okay, we would factor that. It's a trinomial. We should be able to get 2 binomials. Okay, the backs have to be 1s, signs have to be the same, and they have to both be minus. And we could solve from there. X is either going to be positive 1/2 or positive 1. Yeah, so this is really the same equation, except instead of x, we've got cosine theta. So it should factor into 2 cosine theta minus 1 and cosine theta minus 1. So either cosine theta equals 1/2, which happens at pi over 3 and 5 pi over 3, or cosine theta equals 1, which happens at 0 with a positive 1. So my complete solution set is 0, pi over 3, and 5 pi over 3. So we've got that kind of factoring technique. Sometimes you have to get it, in your equals 0 situation first. So if I have sine squared theta, this is example 6, minus sine theta equals 2, okay, it's got to be equal to 0. You could factor a sine out of the front, but that's not going to be helpful, because we have to be equal to 0 for factoring to be helpful. And then now I have the trinomial sine theta. It has to be a 2 and a 1. I'm going to need minus 2 plus 1. So my two options are that sine theta equals 2 or sine theta equals negative 1. Now, this one is a no solution. Sine cannot be 2. 1 is the biggest it can be. Remember, we're talking unit circle. The radius is 1. So that part of it is no solution. The only place sine is negative 1 is at 3 pi over 2. Okay, so think about that. There are a few problems on the worksheet involving, tangent, secant, and cotangent. So just, remember our strategies for those. If you end up with, secant theta equals 2, what's that really saying? Secant's 1 over cosine, so you're really talking about, well, when is cosine 1/2? And you can go from there. So just, we've done those. You can use the same techniques to get to there and work from there. Okay? Hope that's enough examples for you to at least get a good start on that, and we will talk on Monday.